On Canvas, you will have a very large PowerPoint in regards to what we're going to be doing with triangles. We're going to work through some of that in this video. First, let's review over classifying triangles. There are two ways to classify triangles. One is based off of its sides using the terms scalene, isosceles, and equilateral. A scalene triangle is one that has no congruent sides. Congruent means equal, so nothing on a scalene triangle is going to be equal. An isosceles triangle is one that has two congruent sides. And an equilateral triangle is a triangle that has three congruent sides. So when asked to classify a triangle using sides, you're going to look to use the words scalene, isosceles, or equilateral. You can also classify a triangle based on its angles, and these three seem to be more familiar to us. A right triangle is a triangle that has one right angle. Oftentimes, you're going to see the square in the corner identifying that it's a 90-degree angle. An acute triangle has three acute angles. Acute angles are less than 90. And an obtuse triangle is a triangle with one obtuse angle, and an obtuse angle is greater than 90 degrees. Let's classify these triangles based by their angle measures. On part A, we have a 20-degree, a 53, and a 170-degree angle. When we look at this one, we can see that this 107-degree angle is obtuse, so this will classify as an obtuse triangle. B, we have a 63-degree angle, a 27-degree angle, and then we have a box in the corner indicating that we have a 90-degree angle. So this would be classified as a right triangle. And C, we have a 64-degree, a 53-degree, and a 63-degree angle. All three of these are acute, so that makes this an acute triangle. Now let's continue on looking at something else about triangles. And this is going to be a main focus for our 7th grade curriculum. And that is this statement right here. The fact that the sum of the measures of the angles of any triangle is 180 degrees. This means that the three angles inside of a triangle must have a sum of 180. They must add up to 180 degrees. This will help us prove that we have a triangle, but it will also help us find missing angles, like the problem that we have here. This problem says to find the value of x in the triangle. This would also be a good time for us to be practicing our equation writing. Now, based on our statement that the sum of the measures of any triangle is 180, that tells us that if we take our three angles of 53 and 61 and x, that when we add them together, we will get 180 degrees in order to form a triangle. So we've created this equation, and now it's time to solve the equation. First, I'm going to combine the like terms, and that's going to give me 114 plus x equals 180. And now I'm going to subtract 114 from both sides of my equation, and I find that x is equal to 66 degrees. So the use of our equations and knowing that when I add up the angles I get 180 degrees is going to help us find some missing information regarding our triangles. Now, since we know that triangles are going to have a sum of 180 degrees, we can use that to solve problems like what we have here on questions 9 and 10. Now, question 9 and 10, they want us to find the value of x. And this is useful so that once we solve our equation, we can go back and we can actually find how big these different angles are. Now, one thing to keep in mind as you do these is that you are going to have three angles that you're going to add together in your triangle to get you a sum of 180 degrees. So we're going to fill in these three blanks with the three given angles. The first angle we have is 71x minus 1. That's this angle right here. The next angle we have is represented with a 20x. And the last angle that we're given is represented by the box, and we know that is 90 degrees. So now we have the equation 71x minus 1 plus 20x plus 90 equals 180. And now what we're going to do is we're going to combine like terms and then solve the equation that we have. And combining like terms, we're going to combine 71x plus 20x. And that's going to give you 91x. Now we're going to combine this negative 1 and positive 90, which combine to give you positive 89, and they equal 180. So let's now solve our two-step equation. First thing we're going to do is we're going to subtract 89 from both sides of our equation and find out that now we have 9x is equal, or 91x is equal to 91. Now we're going to divide both sides of the equation by 91, and we find out that x is equal to 1. So by taking our three angles, adding them together to equal 180, we can use that to find missing parts or missing variables when we're working with triangles. Let's try one more on this page with question number 10, and then I'm going to move on. So question number 10, we're going to add our three angles. Our first angle is x plus 34. Our second angle is x plus 64. The third angle is the box, so that's representing 90 degrees. And when I add all three of these together, I will get 180 degrees. So now we're going to combine like terms. 1x plus 1x is 2x. 34 plus 64 plus 90 is going to give you 188, and that is still equal to 180. So let's solve our equation. First, we're going to subtract 188 from both sides of the equation, leaving us with 2x equals negative 8. Now divide both sides by 2, and we're left with x equals negative 4. So now we've used that to solve for x. Now with number 10, I just want us to take a second, and I want us to find the value of these other two angles. You already know that you have a 90-degree angle, but we have one of them that says x plus 34. Well, we now know that x is negative 4. So if I want to figure out what this is, I would replace the x with negative 4. So instead of x plus 4, x plus 34, I have negative 4 plus 34. And I find out that this is a 30-degree angle. And I can do the same with this other one of x plus 64 by replacing the x with a negative 4 and adding 64 and find out that that angle is 60. These are things that we're going to be doing as we progress more into the geometry that we're starting to talk about. Okay, so let's recap. So far we've looked at with our triangles that we can classify them by sides, and by doing so we can have a scalene triangle, an isosceles triangle, or an equilateral triangle. We have also looked that we can classify a triangle by its angles, meaning I can have a right triangle, an acute triangle, or an obtuse triangle. We went even further looking at our angles and found that all of our triangles have to add up to 180 degrees. So the sum of all triangles is going to be 180 degrees. And this is something to know because here's a question that I'm going to ask you in the future and throughout this lesson. I'm going to give you three angles: a 50-degree, a 60-degree, and a 70-degree angle. Now, my question is, can these three angles make a triangle? Well, to test that, we're going to add them together. And 50 plus 60 is 110, plus 70 is 180 degrees. So yes, I can make a triangle. So let's try one more. 45 degrees, and we're going to add it to 60 degrees, and we're going to add it to 80 degrees. And I want to know if 45, 60, and 80 can give me a triangle. And when I add them together, I get 185 degrees. That tells me that I cannot make a triangle with those given angles. So testing your angles is going to be very important because we need to be able to determine if I have a triangle. But we're also going to have to look at the sides. And we're going to use a property, and I'm going to sum it up just a little bit differently for you. If I give you 3 sides and ask you if it makes a triangle, I want you to take the 2 smallest sides, all right? So small side 1, and I want you to add it to the other small side, so small side 2. And in order to be a triangle, these 2 sides have to add up to be greater than the biggest side of that triangle. Sound easy enough? Because it is. Let's look at this example. Determine if the lengths of 3 feet, 4 feet, and 9 feet can form a triangle. So if you go back to what I told you, take the 2 smallest sides. Your smallest sides are 3 and 4. And I want you to add them together. Because in order to be a triangle, it must be greater than that 9-foot side. Well, 3 plus 4 is 7. And is 7 greater than 9? No, it is not. So there is no triangle able to be formed. Let's try the first 2 of these, and then I think we're going to move on. We'll do 1 and 3. 1 and 3 are we're going to do, and I want you to do the others as practice. Will 4, 7, and 10 form a triangle? So according to what we did, 4 plus 7, being the 2 small sides, must add to be greater than the third side. 4 plus 7 is 11. Is 11 greater than 10? Yes. Those 3 sides can form a triangle. Number 3, a 7-foot, a 9-foot, and a 16-foot side. Our 2 small sides are 7 and 9, and I want to know, do they add up to be greater than 16? Well, here's the one that's going to throw some of us sometimes, but 7 plus 9 is 16. And 16 is greater than 16? It is not. 16 is equal to 16. You can't be equal. The sum must be greater. Let's keep that in mind as we continue because we're going to keep testing these triangles. All right. Triangles, they can be unique, meaning only one possible triangle. Or they can be not unique, meaning I can make many triangles given those characteristics. But then we have impossible, and we've just been proving those impossible triangles. First, we proved it by angles. And when we look at our angles of a triangle, we know we're looking for that key number of 180 degrees. If it is not 180 degrees, then we say it is an impossible triangle. You just can't do it. But if it does have 180 degrees, we claim it to be not unique. So I want you to cross this part out. Because if you're given angles, you cannot have a unique triangle. When given angles, it cannot be unique. It's either impossible or not unique. But if we do our sides, we're going to take the 2 shorter sides So the short plus the short, and it must be greater than the biggest side. If that doesn't work, it is impossible. If it does work, it is unique. And we're going to scratch out right here on our table, because when I'm given side lengths, I either have a unique triangle or no triangle. Those are my only two options. And we're going to look at a couple of these and try them out before we keep going. We want to know whether the given sides or angles will make a unique, a not unique, or an impossible triangle. So can I make one triangle, many triangles, or no triangle? First one, 8 meters, 1 meter, and 8 meters. These are side lengths. So we need to test it using our side process. Take the two small sides and add them together to be bigger than your third side. Well, 8 plus 1 is 9. Is 9 greater than 8? Yes, it is. So since this is a triangle and I was given side lengths, this would be unique. Number 2, 30 degrees, 70 degrees, and 80 degrees. These are angle measures, so my angles have to add up to 180. So we're going to add 30 plus 70 plus 80, which is 180 degrees. This will make a triangle, but since I'm given angle measures, it's a not unique triangle, because I can make many triangles with those 3 angle measures. And let's try number 4. Number 4 has side measures. So I'm going to add up the two smallest, 1 plus 4, and see if it's greater than the third side. 1 plus 4 is 5. Is 5 greater than 10? It is not. And since I cannot form a triangle here, I am going to say that it is impossible. Number 5. There are some angle measures. Angles have to add up to 180. So 90 plus 40 plus 40, when I add those together, I get 170 degrees. 170 is not enough to make a triangle, so again, this is going to be impossible. Okay, so we have talked about how to classify triangles based on sides and angles. We have talked about the fact that the triangles must have angles that add up to 180 degrees. And we have looked at how to use side lengths to prove if we have a triangle. Add the two small sides together and make sure they add up bigger than the third side. Okay, there are several more practice problems in here that I want you to complete. Practice them, and if you run into any questions, send me a picture of the question you're working on to inbox on Canvas, and I'll get back to you with some extra help. I'll be talking to you soon.